Have you ever gazed up at the night sky and wondered, are we alone in the universe? This thought has sparked curiosity and driven exploration for centuries. Today, we are not just looking at the stars, but beyond them, to a realm filled with planets just like ours, and perhaps, life as we know it. Welcome to the fascinating world of exoplanets. These are planets that orbit stars outside our solar system. Yes, you heard that right. Planets beyond our family of 8. The discovery of these celestial bodies has revolutionized our understanding of the universe. It's like opening a new chapter in the book of cosmic exploration. But what makes these exoplanets so significant? Well, they hold the potential to answer one of our oldest questions. Is there life beyond Earth? With our advancing technology, we are now able to explore this question by searching for planets beyond our solar system, known as exoplanets. Discovering an exoplanet is not as simple as pointing a telescope at the sky and looking for it. In fact, the science behind the search for these celestial bodies is quite fascinating and intricate. To understand the search for exoplanets, we must first understand the two main methods astronomers use, the transit method and the radial velocity method. The transit method involves monitoring a star's brightness over time. When a planet passes in front of the star, or transits, it causes a small dip in the star's brightness. This dip, although minute, can be measured and used to determine the size of the planet and its orbit's length. Now, the radial velocity method, on the other hand, involves observing the small wobble a star makes due to the gravitational pull of an orbiting planet. By measuring this wobble, astronomers can calculate the planet's mass and the size of its orbit. It's a bit like watching a dance between two celestial bodies, with the star and planet, each influencing the other's movements. Both the transit and radial velocity methods have their strengths and weaknesses. The transit method, for instance, is excellent for finding large planets orbiting close to their stars. However, it's less effective at detecting smaller planets or those further away from their star. The radial velocity method, meanwhile, is great at finding large planets regardless of their distance from the star. Yet it struggles when it comes to detecting smaller planets. The beauty of these methods lies in their complementarity. When used together, they provide a fuller picture of the exoplanet, revealing its size, mass, and distance from its star. These data points then help scientists determine whether the exoplanet could potentially support life as we know it. These methods have led to the discovery of thousands of exoplanets, but some stars show more promise than others in hosting these distant worlds. This brings us to the next part of our journey. The top 5 stars considered most promising for hosting exoplanets. But that's a story for another scene. There are billions of stars in the universe, but today, we're going to focus on the top 5 stars considered most promising for hosting exoplanets. First on our list is Proxima Centauri. It's the closest known star to the Sun, a mere 4.2 light-years away. Despite being a small, low-mass star, it has been found to host an exoplanet in its habitable zone. Proxima Centauri b, as the planet is called, could potentially harbor liquid water, making it a prime candidate in the search for life beyond Earth. Next up, we have TRAPPIST-1, a star system located approximately 40 light-years away from us. This ultra-cool dwarf star is home to 7 Earth-sized planets, 3 of which are located in the habitable zone, making TRAPPIST-1 a fascinating target for future study. Our third star is Kepler-22, a Sun-like star approximately 620 light-years away. It is known for hosting Kepler-22b, a planet twice the size of Earth and located in the star's habitable zone. While Kepler-22b's composition is still under debate, its discovery has sparked excitement among astronomers. Next on the list is Tau Ceti, a star similar to our Sun, located just under 12 light-years away. It's one of our closest stellar neighbors and is known to have at least 5 planets orbiting it, 2 of which are in the habitable zone. These factors make Tau Ceti a compelling target in the search for exoplanets. Last but certainly not least is HD 40307, a star slightly smaller and cooler than our Sun, located 42 light-years away. This star hosts at least 6 planets with one HD 40307G within the habitable zone. This super-Earth's potential for liquid water and life makes HD 40307 a point of interest for astronomers. These stars are our best hope in the search for exoplanets and potentially extraterrestrial life. But not all exoplanets are created equal. For life as we know it to exist, an exoplanet needs to be in the habitable zone. This is the sweet spot where conditions might be just right, not too hot, not too cold, for liquid water to exist on the surface. And where there's water, there just might be life. The habitable zone, often referred to as the Goldilocks zone, is a region around a star where an orbiting planet could have surface temperatures that allow for the presence of liquid water. This zone varies with the type and age of the star, and the distance between the star and the planet. Among the 5 stars we've discussed, some do possess planets within their habitable zones. These stars, with their potentially life-sustaining planets, are our best bets in the cosmic lottery of finding extraterrestrial life. The search for exoplanets in these habitable zones continues, with the hope of one day answering the question, are we alone in the universe? The search for exoplanets is only just beginning. As we stand on the threshold of new horizons, we're looking forward to the launch of unprecedented missions that will further our knowledge of these distant worlds. The upcoming James Webb Space Telescope, for instance, is set to take the helm, peering into the cosmos with the most powerful eye ever turned toward the sky. And then there's the potential for new discoveries. Imagine the thrill of uncovering an exoplanet that could support life. The implications are profound, challenging our understanding of our own place in the universe. Could we be closer to answering the age-old question, are we alone? The future of exoplanet exploration is a journey into the unknown. It's a testament to human curiosity and our relentless pursuit of knowledge. As we continue to gaze up at the night sky, we can only wonder what new worlds we will discover next.